When we talk about a program, all of our operations basically come down to just a few things: input, variables, computations, and output. We're now going to learn how we can write programs that touch on all of these aspects of what makes a program. And each of these fundamental tasks of a program corresponds to the main hardware components of a computer. The input and output are handled by an interface with the world. Variables are handled in memory. And computations are handled by the processor, the part of the computer that performs calculations. In the previous lecture, we already saw how we can write programs that create output. This was the console output command, cout, and that made the computer output text to the screen. In this lecture, let's start with a program for counting calories. It involves not only output, but also variables assigned to memory and calculations involving the processor. Okay, let's take a look going through each of the main aspects of this program. Our comment at the top acts almost like a title, telling us that the program is to compute calories using carbs, protein, and fat. The program starts with the same enabling lines: pound include bracket iostream bracket, using namespace std, and int main parentheses curly braces. These first two lines help us get access to the commands that we need, and the int main line indicates where the program should start. The main body of the program has four parts. There are variable declarations, where we give names to variables. There are variable assignments, where we give values to those variables. There's a single computation to calculate calories, and there's output. Later, we'll also modify the program to take in user input, which is a more flexible way to assign values to variables. Variables are handled in memory. So, to understand what's going on with variable declarations and assignments, let's look more closely at memory. A computer's main working memory is made up of lots of locations, each of which is capable of storing just a 1 or a 0. However, as programmers, we don't write in machine language. So, what programming languages do is they let us take a section of that memory, of 1s and 0s, and use it for our own purpose. And this section of memory is what we call a variable. The easiest way to think of a variable is as a box. The box can hold different values. That is, it can vary in what it holds. So it's a variable. In C++, in order to use a variable, we first have to declare it. That is, we have to write in our program an instruction to the computer that says, I want you to set aside a box of memory for me to use as a variable. That operation, stating that we want a particular variable, is called the variable declaration. We're declaring this variable should exist. Every variable declaration is going to need two things: a type and a name. For example, we could declare an integer type variable that we name year. The code for that would be int year, where int is short for integer. Any counting number like 0, 1, or 2, or even negatives like -10. So, let's look at our calorie counting program and go to our first variable declaration. The line int carb grams gives the two pieces of information that we need to declare a variable. First, there's the type of variable, which is int, short for integer. Next is the variable name, which here is carb grams. The variable name is the way that we'll refer to the box of memory. And this variable name is often called the identifier, since it's the way that we identify which box of memory we're referring to. When we refer to carb grams in our program, we'll be referring to that box of memory, and more specifically to the value contained in that box of memory. Now, likewise, our next line of code is another variable declaration. We're telling the computer, set aside another box of integer type memory that we will call protein grams. Every variable declaration sets aside a box of memory, and that box will have some value inside of it. But setting aside a box of memory that's just a bunch of ones and zeros would be a pain to deal with if we had to write the ones and zeros of binary ourselves. The way that we get the ability to write variables in a form that we understand is with the variable type. When we declare a variable, we first tell the computer what the type of that variable will be. And C++ is called a strongly typed programming language because we always have to specify the type whenever we declare a variable. In our example, the type is int, which means that the programmer is free to think of the box as containing an integer. The computer will handle the process of converting that integer to and from the binary form. As a programmer, we don't worry at all about how the computer is actually making the box, and we don't worry about converting our values into binary and back again. We just say, we want a box of memory, and we declare the type of data that will be in it. So, each variable declaration is going to have two parts, variable type followed by a variable name. And in our code, we can see 4 variables being declared. Each one is of type integer, and they have different names: carb grams, protein grams, fat grams, and lastly, we have calories, which is the variable we're looking to calculate. Now, you could avoid typing int over and over if you want. You can put all of your variable declarations on one line. Just begin by telling the computer the type for all the variables on that line, int. Then you can just list each of the variables that you want to declare, separated by commas. Carb grams, comma, protein grams, comma, fat grams, comma, calories. Now, let's look at variable names, which have a few rules. Names have to begin with the letter. Besides letters, it's also possible to start with the underscore character, but you should not do that. Variables starting with underscore are usually reserved for special things in the compiler, which come up in more advanced systems programming. As for the rest of the name, you can use letters, underscore characters, or numbers. Yes, a variable can contain digits or underscore, but it can't start with digits. And there are a few dozen special words in C++, often called keywords or reserved words, that are already used for other things, so you can't use those. For example, you cannot name a variable namespace or using. There are also a few predefined identifiers like main that would be possible to declare, but you should just avoid that in your own variable names. As you learn more C++, you'll encounter more of these reserved and predefined words, and most are very easy to avoid. As long as you follow the rules, choosing the names for variables is up to you as the programmer. And this is one of those areas where programming becomes more of an art. Sometimes it might seem like it doesn't really matter what you name your variables. I mean, the computer won't care if you name your variables something like carb grams or something that's nonsense like Jabberwocky. But choosing good variable names is one of the most important things you can do to make your code more understandable to yourself and to anyone else. If you make it your goal to write working code that's easily comprehended, that will also help you in your primary goal of writing code that works, period. So, as you choose variable names, choose names that give a clear sense of the meaning of what that variable is intended to hold. Don't choose names that are too short or too long, and try to be consistent in your names. For instance, if I named a variable carb grams, I should pick a name like fat grams, rather than something like grams of fat. Okay, let's do a quick exercise. Which of the following would be okay to use as variable names? A few of these are not valid names. You cannot use a reserved keyword like namespace. You can't have a space in a name, so left space foot is not allowed. You need to use underscore if you want separate words. A punctuation mark such as exclamation point is not allowed in a name. So success exclamation point is out. And no, names can't start with a number, so we can't have second underscore account. A couple of these are good names. They're valid, and they at least give some information about what the variable is supposed to hold. Tank underscore capacity and length 2 are both valid and somewhat descriptive. The single letter I is also valid as a variable name. Now, there are actually circumstances where we'll use the single letter like I that we have here as a variable. In math, you might have a value like x and use I as a subscript or superscript. Then there are a couple of names that are valid but probably not great choices. Naming a variable something tells you too little about what it's supposed to hold. And a name like account is not horrible, but it's not really clear what value it stores. Is it the account balance, or the account ID, or the account name, or what? A name like account underscore balance would be a lot easier to understand. Okay, going back to our calorie counting program. What if we wanted to get more precise and use decimals for the number of grams or calories in our program? Well, a decimal is called a floating point because the location of the decimal floats around. Compare the decimal in 1.1 with 99.999. To designate a variable as a floating point type, we write float. So, we just go through our program and replace every int with a float. Once we've declared variables, whether as integers or floats, we need to be able to use them to actually store information in that box of memory and look at it later. Let's look at our calorie counting code again. After our declarations of type and name, you can see that we have 3 variable assignments. Each of these lines has the same form: a variable name on the left, an equal sign, and a value on the right. And we read this: carb grams is assigned 30, or carb grams gets 30, and so on. This is the general form for any assignment statement. We have a variable name on the left, what looks like an equal sign, and then a value on the right. And when this code is executed, the value on the right-hand side is placed into the variable on the left-hand side. It's placed into the box. It replaces any other value that was already in that box. So if we have a line like carb grams equal sign 10, that means that the box of memory that we call the variable carb grams will have the value 10 assigned inside of it. Now, there's one thing about assignment that I want to really emphasize because I've seen it trip up a lot of people who are first learning programming. Assignment is written with a single equal sign, but it does not mean that two things are set equal to each other. It means that the thing on the right is assigned to the variable on the left. That's why it's better to say gets or is assigned instead of equals when we read a line of code out loud. And this takes some practice to get used to. Carb grams is assigned 30. Protein grams is assigned 5. Fat grams gets 15. Let's take a look at the first few lines of how our code works in memory. First, we have a variable declaration, declaring a box of memory for an integer variable named carb grams. Next, the same thing happens when we declare an integer variable for protein grams. And we declare an integer variable for fat grams. So, at this point, we've got 3 different integer areas of memory with 3 different names. Now, we assign the value 30 to carb grams. This means that the box of memory for carb grams now contains the number 30. Then we assign 5 to protein grams. So that variable now holds the value 5. And finally, fat grams gets the value 15. Remember that variables can vary in value. They aren't stuck with the first value that they're assigned. And that's why the single equal symbol means assignment, not permanent equality. we can come along at any later time in the program and assign a new value in the box, replacing the old one. So it is completely okay to assign a value to a variable in one line of code, like fatgrams gets 15, and then later assign another value like fatgrams gets 10. After both lines of code are executed, the variable fatgrams will have the later value of 10, and it'll be completely forgotten that it ever had the earlier value 15. Now, you might have asked yourself, when we declare a variable, what value is there in the box to begin with? And the answer is that there is something there, but it's undetermined what it is. And that doesn't sound good. We don't want to have variables sitting around there with who knows what inside of them. So, when we first declare a variable, it's a good idea to set an initial value to be in that variable. It turns out that this is easy to do. We can combine the variable declaration with an assignment. So, the code that we just saw, where we declare three variables and then assign initial values to all three, can be combined into three statements that declare and initialize variables. And it's more compact. It only takes 3 lines of code instead of 6. Variables wouldn't do us much good if we couldn't ever use the value that they hold. When we see a variable name on the right-hand side of the assignment operator, we can think of what's there as meaning the value that this variable holds. Now, let's look at our computation for calories. Here is where we're using the variables carb grams, protein grams, and fat grams. This is a mathematical calculation, and the asterisk means multiplication. In this line of code, we're adding together 4 times the value stored in carb grams, 4 times the value stored in protein grams, and 9 times the value stored in fat grams. So, here's the calculation the computer will be doing for us. Carb grams holds the value 30. So, 4 times 30 is 120. Protein grams holds the value 5. So, 4 times 5 is 20. And fat grams has the value 15. So, 9 times 15 is 135. Adding up all of those gives us 275. It's our program's job to calculate the value, and we assign that value to the variable calories. Notice that we first calculate the value on the right-hand side, and then we assign that to the variable on the left. Okay, let's look at how we output the result of our calculation. Previously, we used console output, cout, to stream text to the screen. Well, we can stream more than just text. We can also stream values from a variable. For example, we could just output the value of our variable calories by putting that variable between the streaming operators, the double less than signs. Going further, we can have an output line where we're streaming to cout first some text, then a variable, then some more text. First we have the text, there are. Next we have the variable, calories. When we get to this variable name, what will be output is the value that's in the variable calories, which in this case is 275. Then we stream out some more text, calories in this dish. And finally, an end of line to end the line of output text. And remember, we always need a semicolon to end the command. So, the net result when we run this program will be to output one line saying, there are 275 calories in this dish. Now, try a quick example on your own. See if you can write a program that has 2 variables, weeks and days. Initialize weeks to 20. Then, have your program calculate the number of days and output a statement giving this information. Got it? Give it a try. Here's what that code might look like. First, we have our standard lines. A comment that tells us what the program is for, #include IOStream, using namespace standard to get us access to the commands we need, int main with parentheses to designate where to start the code, and the first half of curly braces to open up the block of code that we want to execute. Now, in this case, the code has two variable declarations. We declare an integer variable, weeks, that we initialize to the value 20. Int weeks equals 20 semicolon. We always need a semicolon to end each command. We also declare an integer variable, days, semicolon. Now, for the number of days, we can assign the value of a computation of the number of days in the given number of weeks. We multiply the value in weeks by 7 and assign it to days. That is, days gets weeks asterisk 7 semicolon. Or we could declare and assign the value of the computation on a single line. Int days gets the value from weeks times 7. Finally, we can stream the results to the console, writing "there are" inside quotation marks, then the number of days, then the words "days in" inside quotation marks, then the number of weeks, and finally the word "weeks" inside quotation marks, followed by an end of line. The result streams together as "there are 140 days in 20 weeks." Now, let's try reading a short program. See if you can figure out what values this program outputs. Notice that we declare three variables, x, y, and z. X is initialized to 3. We then assign x to y so that y has the value of 3 also. Next, z gets the value of x times y, which is 3 times 3 or 9. So at this point, both x and y are 3 and z is 9. Then we assign the value 5.5 to x. Y and z are not affected. So when we stream the values of the three variables to output with the cout statement, we get 5.5, 3, and 9, separated by spaces. Let's take a look at some other interesting things we can do with variable assignments in basic computations. I'll illustrate with our calorie counter code. Anytime you make an assignment, you want to first evaluate the code on the right-hand side, and then once you know the value, assign the resulting value to the left-hand side. In this example, we've added a line that we might encounter if we were adding a little bit of extra butter or other fat to the recipe. It's still fat, so we don't need a new variable. Instead, the new line of code is fat grams gets fat grams plus 1. Now, that wouldn't make sense if this were an algebra equation. But remember, this is an assignment. So in terms of code, the way to think about it is that we first evaluate the right-hand side, substituting in the value of any variables. In this case, we start with the value fat grams at 15. So the right-hand side of this statement evaluates to 15 plus 1, or 16. We then assign that value, 16, to the variable on the left. And it so happens that the variable that gets the new value is again fat grams. But that's not really a problem. We've already figured out the value to use on the right-hand side. The end result is that the value stored in the variable fat grams has been increased by 1. Now, that operation, where we take a value of a variable, we add something to it, and then we assign the end result right back to the original variable, is actually fairly common. We often want to modify a value rather than assign a totally new value. In fact, modifying existing variables like this is such a common operation that C++ has a shorthand way of writing the same operation. The way this is done is with the notation plus equals. For example, when you have the plus equals 1, it's doing exactly what we just saw. It takes the current value of the variable, adds the amount 1 from the right-hand side to it, and then it stores the result as the value of the variable. In general, the value is increased by whatever the amount on the right-hand side is. So the line you see here, fat grams plus equals 1, is doing the exact same thing as the line we had before. Fat grams gets fat grams plus 1. It works the same for subtraction. If you have money in the bank and withdraw $100, then your money in the bank is minus equals 100. Multiplication too. If you have rabbits, then pretty soon you may triple your number. In other words, the number of rabbits times equals 3. These compact operators can take any number, but the most common is to increase a variable by the number 1. Think about counting. If you have a number, you usually count by ones, increasing the number by 1 each time. And we say that we're incrementing the variable. So there's an even more compact way that you can express incrementing, and that's the plus plus operator. So what's the value of 1999 plus plus? That would be 2000. Your age right now plus plus would be your age a year from now. In our code then, we can write fatgrams plus plus. So we have 3 ways to write the same line of code, and they all do basically the same thing. Fatgrams gets fatgrams plus 1, or fatgrams plus equals 1, or fatgrams plus plus. All 3 work the same. The value in the variable fatgrams is increased by 1. And because 1 gram of fat is 9 calories, we end up with 9 more calories than the previous result, so we get 284 instead of 275. So, now you know where the language C++ gets its name. The plus plus means the next increment above the previous value. In the case of C++, it's the next language after C, in that it was designed to do whatever C can do and then go one better. The plus plus means going to the next step. Just like there's a plus plus, there's also a minus minus, which will decrement by 1. If we used 1 less gram of fat in our recipe than usual, we could write fatgrams minus minus. And sure enough, we end up with 9 fewer calories, 266 instead of 275. By the way, C++ also lets you write the increment operator before the variable name, but they don't always mean quite the same thing. Putting plus plus after the variable, like x plus plus, means you increment the value of the variable to something new after doing the parts of the command that were already there. Here, printing x plus plus gives the initial value of 1. Putting plus plus before the variable, like plus plus x, means that you increment to a new value of the variable before doing other parts of the command. So in this code, printing plus plus x will print the new updated value of 2. Let's also take a quick look at how C++ supports mathematical functions. Here we have 2 variables, a and b, and they're assigned the values 12 and 3. Now notice that we can stream an expression like a plus b directly to output. When this kind of line is executed, the math will be done first, and the result is what's output. Now notice that multiplication is with an asterisk, division is with a forward slash. In this case, outputs work as you'd expect. A plus b is 15. A minus b is 9. A times b is 36. And a divided by b is 4. Well, how do you think things work when division doesn't occur evenly? What happens if we divide 7 by 3? Well, when C++ sees division by 2 integers, it does what's called integer division, meaning that it returns only the quotient with no remainder. Since 3 goes into 7 2 times, the result is 2. If we want to find the remainder from division, we can use the modulus operation. The modulus operation is represented with a percentage sign. And this will give us the remainder, and only the remainder, when one number is divided by another. So, if we combine integer division with modulus, we can get the quotient and remainder from any division operation. For the code you see here, the first cout line will output the quotient, 2, like we saw before. And the second cout line, where we stream out a percentage sign b, that is a modulo b, will output the remainder 1, which is the remainder of 7 divided by 3. Finally, let's talk about input, which is handled very similar to the way output is handled. Values are streamed into variables. For input, we get our input from the user typing in data into a window. This window is again referred to as the console, so we use the term cin to designate that we have input from the console. And just like the output indicated that the stream of information should flow from variables leftward into cout, for input, the information will flow rightward from cin to the variables. We have the input data that the user is typing in the console window, so that the data flows or streams into the variables that follow it. So we'll use a double greater than sign to designate this. The direction of the stream of data is from cin to the variables. Take a look at the modified calorie calculator code that we have here. Now first, there's a stream operator with output for the console, giving the user instructions on what to do. In this case, the user is to enter the grams of each type. Next, we have 3 cin lines to indicate input that we'll get from the console. The first of these indicates that the first thing the user types will be stored in the variable carb grams. The second thing the user enters will go into protein grams, and the third into fat grams. In short, now the user can choose the grams of each type, instead of having those values stuck on the initial values set in the code. If we run the program and we enter the values 10, 20, and 30, for instance, then we get an output telling us that there are 390 calories in the dish. That is, a dish with 10 grams of carbohydrates, 20 grams of protein, and 30 grams of fat will have 390 calories. Just like the output streams could be combined with multiple stream operators on each line, we can combine multiple input stream operators on one line. The input line that you see here is the same as the 3 lines shown previously. We still read the first piece entered into carb grams, the second protein grams, and the third into fat grams. Running the program gives the same output as before. Now, what if we wanted to ask users for carb, fat, and protein grams using 3 different questions? Well, we could just have 3 different cout output lines, each saying what to enter. Each is followed by a separate cin line, reading values into each of the variables. Now, whenever you get input from a user, there's always a chance that they'll do something unexpected. In the examples we just saw, we were asking the user to enter grams, but we didn't tell them to use integers. So if the user had entered an unexpected decimal number like 2.5, then the number would just be truncated. Any part after the decimal would be dropped off. And if the user had entered something totally different, like words for 10, 20, or 30 instead of numbers, then the answer might be 0, or possibly create an error and stop the program. We'll see how to deal with this sort of problem in Lesson 14, when we learn about handling exceptions. Variables are key to any program, so remember, you always have to declare a variable first, and when you declare it, you have to say what type of variable it will be. And these variables are like boxes that can be assigned a new value to hold at any time. We can also use the values that variables hold to perform computations. Stream operators allow us to stream input into variables and then to stream variables or computations to become output. In the next lecture, we'll learn about a new type of variable, the Boolean, and we'll see how we can use it to let our programs make choices. See you then.